Greetings and welcome to episode 23 of the Sustaining the Herd podcast, brought to you by Sechi Agri-Services and Engineering of Raymond, Nebraska. I'm Andrew Wadle, and I'm joined in the studio by my co-host, Brock Vitek. First, I'd like to start by saying welcome back to our faithful followers. We're glad to have you. And also welcome to our new listeners. And for everybody new, just to tell you a little bit about Sustaining the Herd, really what we do is talk about everything sustainability related to animal agriculture. And you can imagine sustainability really covers a lot of topics. And just really briefly, well, it could be sustainability in preserving the air and water that we breathe and drink, and it could be sustainability when it comes to maximizing using resources. So our world population is growing all the time, and as they say, they ain't making no more land, and so we need to be doing more with less, just to feed the population, as well as to take care of the byproducts that are produced. And lastly, but certainly not least, is we need to have sustainable businesses. So our businesses need to be profitable in order to be sustainable, so that they continue to do what they do. And so today, in addition to Brock, we're joined in the studio by David King and Tom Quimby, who are associated with Cummins Incorporated. And most of you probably think of Cummins or are aware of Cummins when it comes to over the road diesel engines, but boy, are they doing some exciting things when it comes to engines and renewable natural gas. So with that, I'm going to turn it over to David and Tom to introduce themselves.
Sure, I'm David King, and I'm the product manager for natural gas engines for the North American on-highway truck market here at Cummins. So I've been with Cummins for now my 37th year. So excited about the market and excited to be here with you all today.
Great. And I'm Tom Quimby, and so longtime commercial vehicle journalist, 10 years now in the business. And so I've written for various periodicals, Commercial Carrier Journal, Overdrive, Hardworking Trucks, Little Landscape Care, covering Class 1 all the way up to Class 8, which would be your tractor trailers. And now, of course, freelance writing for Cummins.
Excellent, gentlemen. And David, would you just kind of give us or both of you, please, give us just a little bit of the history of Cummins?
Sure. Cummins started here in Columbus, Indiana, which is my home as well, and started by Clessie Cummins. And so he saw the opportunity with diesel engines or oil engines way back in the early 1900s and really started the innovation in that regard, putting very much a demonstration kind of guy and putting engines into various types of transportation and into ag for farm pumps and things like that. Actually, the very first Cummins engine went into a commercial truck in 1934, and that began the transition to dieselization in the heavy-duty truck market. So back in those days, it was horses and gasoline, and now the Class 8 market is diesel and natural gas.
Yeah, and as a reporter, I had the pleasure of actually going to Cummins Museum there in Columbus, Indiana. That was a real treat, getting to see a lot of those engines on display, just spanning the decades. And as David had mentioned, that start in agriculture, and they still have a functioning engine, one of the earliest, in fact, the earliest that was ever put on the market. And I think it was, 1905 or thereabouts, David?
Yeah, I think it was 1919, somewhere around there.
Yeah, early. Yeah. So this thing still runs. In fact, they had found one on a farm out in California. It was well preserved. Cummins had acquired it, and it's on display there in a museum. They started this thing up, and wow, it's still working. Okay, it can just hand crank that flywheel, And you have a open water cooling system. It's not a pressurized cooling system that we're used to, right? So it's actually a water tank on top. It's super interesting to see this work and just chugging along, okay, 100 years later and still running strong. That was super impressive. A real treat there to go to the museum.
So, guys, I know Brock is just busting to ask you guys some questions, but I'm going to ask one more before we keep rolling here. So, Tom, you see it all, I think, when it comes to engines and things and across industries. Where do you see Cummins engines being used? Give us a sense for what that looks like.
Right, yeah. So, Cummins is just covering, just all vehicle classes, right? Class 1 all the way up to class 8. And it's pretty darn amazing, right? So you can get repower Cummins engines in case you've got, projects or want to repower your Jeep. You can get a small diesel engine to do that. All the way on up, like I said, to the class 8 X15. And of course, there's industrial size generators. That's a very big growing market for Cummins with AI and data centers that are very demanding for it comes to energy. And so, some of these engines are needed there in regards to extra power, right? Backup power. Applications and ships, obviously. Cummins is really hard at work, okay, and just so many different modes of transportation, and again, also in energy too, backup energy. So it's pretty darn amazing. They're all over the world. There's hardly a country that doesn't have Cummins available there. It's amazing. So. For me, right, would I cover class 1 to class 8, right? Because I'm not going to go ahead and look at shipping so much actual container ships, so much of what's powering them, but really transportation on road, and of course for pickups. The 6.7 liter Cummins has been, active for years. And prior to that, of course, was the old 5.9, which came out swinging hard, right? And Ram pickup, which, a great partnership that has continued for decades now. And so just great reliable power, right, in the pickup segment for sure. And of course, it goes up from there, right? You're going to get into your larger trucks, right? Whether it's a box truck you see on the road, okay, sometimes called a straight truck, right? And it might be, 2-axle, could be 3-axle, and then you get into, your tractor trailers, right, which are the big rigs, as they're sometimes called, right? So, it's really across all vehicle segments, where Cummins has been hard at work, for an awful long time, and so it's also been something of interest. And, David, I think we can, of course, allude to this, is that, Cummins is getting involved in gasoline engine space as well, right, with the 6.7 octane. So, that does open up the possibilities, okay, for even more applications, right? There's going to be some customers that it might be more ideal for them to use gasoline, versus diesel. And so they could have that option, right, with a 6.7 gas variant. So they're constantly pivoting, which is, really important for a company, especially now. And they're always innovating, right, studying the market closely, and keeping, obviously, a close eye on various policies coming out of DC to respond accordingly. It's fascinating, right? And I'm always impressed, with the moves they've made. Okay. Definitely.
Tom, you gave the perfect lead up to what I was wanting to ask next.
Okay.
And I'll pose this question to both of you guys. First, I'd like to ask, what are the trends that you're seeing in over-the-road truck fuels today? And as a follow-up, what has driven Cummins to enter the renewable natural gas engine arena as well?
Yeah, so I'll take the first stab at it, Tom. And Brock, what we're seeing is, diesel has been ubiquitous for many years, many decades, I should say, in Class 8 or heavy-duty truck. And, we saw the entrance of natural gas back in the early 90s. We saw biodiesel start coming on, which still continues to grow. Natural gas is growing more now that there's some more product availability, and we'll talk about that some more. And then there's renewable diesel. So those are kind of the mix of fuels that I think you're seeing upticks in all those different variants to what is the traditional just general diesel for our market segments in the on-highway space.
Well, I was going to say, yeah, it's interesting too, because, with the production of renewable diesel, we're seeing a spinoff of that. And so during the production of renewable diesel, they're pulling off renewable propane, right? Which has gotten some traction in California. It's on the edge. It's not a widely used fuel, but it's interesting though, that there is another variant there, to consider. So, we're far from over there, I think, in terms of renewable fuels.
Yeah. And looking kind of out further, hydrogen, right? Hydrogen's a fuel that, is, again, there's a lot of policy such oriented at that. And so, Cummins continues to innovate there for different hydrogen powertrain solutions, fuel cell, in hydrogen internal combustion engines. So that'll be another gaseous fuel that will come to trucking in the future. And Cummins definitely intends to be a part of that.
Sure. It's interesting, guys. You talked earlier, David, about, back in 1934, was it, the first Cummins put the first diesel engine in the truck? Was that correct?
Yeah, they're plus or minus a year, I think it is.
Sure. All the way up to today when you have renewable natural gas engines or, biodiesel, things have really evolved. And a lesson I'm taking away from this is if you want to stick around and be in business for a while, have a sustainable business model, you probably won't be doing things the same 50 to 100 years from now as you are today. It takes some innovation and some evolution of what you're doing over time. And sounds like Cummins has done exactly that. You're in the engine business, but you're not doing things the same way today that you were back in 1934. You're looking at the trends and seeing where those are going.
Yeah, definitely. We're continuously innovating, whether it's different technologies on the engines for improving the emissions, improving fuel economy, both which have just improved over the years collectively, right? The engines today are far more fuel efficient than they ever were and produce the littlest or fewest amount of pollutant criteria that they've ever produced. So they're the cleanest and the most fuel efficient products out there. And then there's the innovation on fuels. And, we talked about diesel, different forms of diesel and natural gas. And when I say natural gas, that includes renewable natural gas, which, that is the trend in the industry for natural gas vehicles, is using renewable natural gas to be more sustainable, reduce your carbon footprint.
And so as far as Cummins getting into this space, this is kind of like a knockoff of what Brock was talking about. What this may be a chicken or an egg type of conversation, but was it Cummins? Did Cummins see it and react, or was there pressure from the regulators in California that made Cummins move in that direction, or kind of what was the sequence of things there?
Yeah, so back in the late 80s, I think it was, Cummins started working on natural gas L10 engines, conversion of our diesel engine in the 10-liter space to natural gas. And it was really targeted at some of the requirements for California. And, first beachhead for that product was in transit buses. And from there, that grew to L10 gas engines into truck. And then the advent or innovation for our B series gas engine and C series. And then it just sort of took off from there to broadening out the portfolio to 9-liter and then to 12-liter. And then last year we launched the 15-liter space. So, it's being driven by some of the emission requirements and regulations, but then it's also been driven by economics, because the total cost of operation for natural gas, renewable natural gas engines is so much less than the diesel alternative that it can become a very economic advantage. So when you think about sustainability, I think, Brock, you mentioned it, and Andrew as well, is sustainability. It's only sustainable when it both provides the environmental and social benefit, but it's got to be an economic benefit too, to keep it around and make it sustainable.
Yeah.
Just adding to that, Cummins, of course, had done a report about TCO, natural gas, versus diesel. And it's pretty eye-opening. It's on the Cummins newsroom. We've got a lot of great articles there, actually, if you get a chance, check it out. So this article comparing diesel, right, to natural gas costs. And so let's say over about 1 year span, if you're using about 10,000 gallons of diesel gas gallon equivalent, or DGE, you're going to save $12,600 using natural gas, right? Versus diesel. And plus, you don't have to worry about DPF. That's a big burden for a lot of fleets, right? Is the diesel particulate filter maintenance, right? That part of after treatment that's necessary, for diesels to meet those emissions goals, right? To filter that diesel exhaust, right, as it comes out of the engine. The DPF, right, filter can get clogged, has to be cleaned periodically, and that can prove pretty costly depending on various factors. Upwards, say, $700, $800. You're not going to deal with that, right, when you've got a natural gas engine. Right. So that's one less headache as well. That adds up, right, for that better TCO.
Tom, when we were kind of preparing for the podcast, we had talked a little bit about emissions, and you made a very interesting point about the quality of the air intake versus the quality of intake that's exhausted in some areas. Can you want to talk about that a little bit, because that's just astounding.
It really is. It's pretty amazing. The first time that I heard that, and that was from a Cummins engineer, and I thought, wow, it's amazing. And if you think about it, it makes sense. And so, depending on which part of the country you're located in, there are what are classified as non-attainment zones. That's in regards to air quality. EPA designates them. California has got quite a few of them because it's the most densely populated state in the country by far, lots of people. And it has a varied landscape, a lot of mountains. It can trap a lot of pollutants, whether they're naturally occurring or they're man-made. And so it's had that kind of history. So you can take, say, an engine, like the X15N. It's got near zero emissions, which is, amazing. Or even the latest 2027 X15 that's coming out. That technology is so advanced, right? It burns so clean that in an area that's prone to having airborne pollutants, particularly particulate matter, well, the engines will go ahead and that comes into the air intake and it goes through combustion, and so it can reduce those pollutants during combustion. So it comes out of the tailpipe, right? Actually cleaner, right, than the air coming in. And that's amazing, right? It's absolutely staggering because, of course, zero emission technologies, they cannot achieve that. Again, that depends, where you're at. So if you're in a historic, it's going to be an area that historically has been plagued by, air pollution issues, that's a big benefit, right? Big benefit. And so it's something that a lot of folks don't realize. But it's just, again, testament to the innovation there at Cummins.
Yeah, that's awesome. And so that's kind of lead into a question I was going to have for you, David. One of the major differences between typical traditional diesel engine and engines that would run on renewable natural gas would be emissions, clearly. So can you just give us a sense as far as what's different about these engines as compared to a conventional diesel engine? And I will add that I'm a recovering gearhead, and so this stuff I really, really like to talk about this. So Brock, you might have to pull me back in. And so, we
I
start
will.
talking, and so for those of you who aren't schooled in the metric system, 15 liters is 900 cubic inches, and so that's a big engine. And these renewable natural gas engines are 15 liters. And can you tell how excited I'm getting about this? Go ahead, David. Tell us what's the same and what's different when it comes to these engines.
Andrew, I'm glad you're excited because I get excited talking about this stuff as well. Really, there's a lot of commonality, right? So we talk about differences, but there's a lot of commonality from the foundation of the engine. When you think about engine blocks and oil pans, lube pumps, water pumps, all these things that are the foundation of the engine, sort of the subsystems that keep it running. Where we start the differentiation is in the cylinder head. We need to have a cylinder head that's compatible with the type of combustion we're going to do with spark plugs. Now doing spark ignited combustion instead of compression ignition, where diesel engine doesn't have spark plugs. So we've got coils to then fire those spark plugs. We have different air handling. We still have EGR systems. We have turbochargers to get more air into the engine. We use a throttle to control the airflow to the engine. And then, maybe obviously the fuel system is going to be different. We're now injecting a gaseous fuel into the intake system, and then it mixes in that intake and goes into the cylinders. And all that fuel is stored on the vehicle generally speaking, the popular method is in gaseous form in a compressed natural gas fuel delivery system. And that means it's got high pressure cylinders mounted on the truck itself. In today's world, those are what we call Type 4, so they're carbon fiber wrapped polymer cylinders. And we stack them maybe behind the cab of the truck or on the frame rails. And they're just incredible technology in the lightweighting and the packaging that's happened to be able to provide the most fuel at the lightest weight possible. And that's wildly different than, say, a 50 or 150 gallon diesel fuel tank, which is just pretty much a big drum on the side of the truck that you take fuel out of and return some fuel to. So these fuel delivery systems are pretty high tech. They have control modules inside, pressure regulators, and valves and such, relief valves, and they're pretty indestructible as things go. So that delivers that gaseous fuel to the engine at the right temperature and the right pressure. So in the end, we have a highly functioning, very low emission, highly efficient natural gas engine or truck.
And is there a comparable diesel size and displacement that would say match up performance wise with the X15 renewable natural engine that runs on renewable natural gas?
Yeah, just only in the fact of our own diesel engine. So when we thought about what we needed to match for the market, the heavy duty market, we looked to our own diesel engine and said, okay, this is the power, this is the torque, this is what the customer expectations are for performance. So delivering an engine that can do that. But at this point in time, there's no other natural gas engines in the marketplace to service this heavy duty market.
Right. I think what I was kind of referring to was so the X15 is a 6-cylinder 15 liter. So the Cummins diesel equivalent that you would have, would it be a how many liter? How many cylinder?
It'd be a 15-liter engine as well.
It would. Okay.
Yeah, 6-cylinder. So really kind of those differences being from the head deck and above, which is kind of what I was describing.
Okay.
So
gotcha.
our what we call our strategy is HELM, which is high efficiency, low emission, multiple fuels. Is we're trying to keep as common or as similar components as possible, and only differentiate where the fuel type requires differentiation, and that's where the combustion's happening. So pistons are a little bit different, and then cylinder head and air handling and fuel delivery system. that's where the changes happen. That way we can really bring scale to these we call them alternative technologies, but as they grow, they become part of the mainstream.
Yeah, absolutely.
So guys, what are the obstacles to wider adoption for RNG engines such as the X15?
Well, I mean, I think a lot of folks, it's just getting familiar, right? With the latest, greatest, the X15N, and there's a lot of great reports coming in from the field with fleets at work using the X15N and really hard to work areas. Okay, whether it's Canada. Jim Park, longtime journalist, well respected in the business, reported on that up in Canada. And the X15N has taken on some pretty tough topography. You got a lot of tough terrain, hills there in Canada, and obviously frigid temperatures. And the X15N is doing really, really well. Jim was singing high praises about it there for our neighbors there to the north. And then with David, there was I think Ozinga out there in the southwest.
Yeah, Ozinga with Bertha.
Yeah, right. And how much were they hauling? They were
they're over 120,000 pounds of milk that they're hauling out there. I say Bertha, Tom, because that's how they've named their truck out there that they've been testing the X15N with. I love it.
Yeah. No, and it's just amazing, right? So a lot of folks that were concerned about capability because they're used to diesel, right? And I just reached out to a friend of mine, actually, he's a truck driver up north, and I was just picking his brain, hey, have you seen anybody with X15 in there? And he's actually driving a truck with an X15 in, and he's been driving for over 30 years, since he got out of high school. And he loves it. Okay, so that that was great, to hear that. I didn't expect that, but so a friend of mine is actually driving one, so that's really neat. So I think that's critical as you get more feedback from people that are actually using the truck with the new X15N, and they get acclimated, and it's fast fuel time, right? No worries there. Plus, of course, right, you're improving that ESG score. If it's a company, a fleet that's concerned about their emissions footprint, they can, quickly reduce it, with RNG, which has become a lot more widely available. And I think that's part of it too, is needing increased education about RNG, right, and the benefits. It certainly has caught on, quickly. I've been studying RNG for 10 years, right? And just to see the growth, it's been phenomenal over the past, 10 years. And so particularly in California, right, they've got more trucks running there in that state, and with their pollution issues, it has been adopted, heavily. And so I was, looking at some figures. And so right now, this is from the RNG Coalition, which, great source for me as a journalist. But right now, California is at 97% RNG use for their on-road vehicles. 97%, right? The natural gas that's used in vehicles in California is RNG, right? And pretty fascinating. It's just through the years has just pushed out fossil-based natural gas, which still obviously plays a significant role. But it's the numbers, right? It's a numbers game. So when you use RNG, what you're doing is you're taking methane that otherwise would have been released to the atmosphere. You're taking that and you're turning into a usable fuel. And methane is considered to be 27 times more destructive, right, to the ozone layer than CO2, than carbon dioxide. So it has stellar scores, right, in terms of its carbon intensity value. Right. So nothing can compare to it. So every month, California Air and Resources Board, right, they put out a report through the LCFS, right, and you can check it out. And it has right there, and it's been there for years. Renewable natural gas has the best score, lowest score possible, gets into the negatives, right? So the most current was about minus 600. And that's because, again, you're taking methane out of the equation that is considered to be really just volatile, very destructive to that ozone layer, right? Okay, so removing that gets you that really stellar carbon intensity value, right? Which then for fleets can add up to, carbon reduction credits, right? And it again, it's a numbers game. And so I think it's a matter of, educating fleets, making them, aware of the fuel, and you can drop it in anywhere. RNG has the same molecular structure as fossil-based compressed natural gas. It's an amazing network of pipes, right, distributed across the country. It's like 3 million miles. The U.S. Energy Information Administration, you can look at their website and see all these pipelines underground. And there's no other country that can compare. It's amazing what we've got here in the U.S. And our friends to the north to a certain extent, but U.S., tons of pipelines, right, underground, going all over the country. And you can produce RNG, right, in the Midwest, or doesn't matter where. You drop it in that pipeline, okay, and, hey, distribution across the country. So that's not an issue, right? But I think it's education, honestly. Through the years, I've noticed that. I've written about it a lot, and still there's a lot of folks that aren't, aware of it. They're not quite, what is this stuff? Where does it come from? There's obviously different sources, right? There's a lot of different sources from cow manure, et cetera. So landfills, you name it.
Yeah, and I think what's really interesting too is, and I have some very good friends who are truck drivers, and I think they would even probably agree that trucking is a very traditional type of industry, and that it's they do these things very, very well and getting more efficient all the time, but probably could stand to look in some new directions as far as where maybe we need to be doing some things differently.
Mm-hmm. I wanted to add too, I forgot to mention that I had an interesting phone call with the California Air Resources Board, because I've been looking at that chart, right, for years when it comes to carbon intensity values for various fuels, right? So I've noticed electric was starting to drop. It was starting to drop through the years. And I thought, I got to call CARB and find out, why is electric score, their carbon intensity value, getting better? And I had a hunch, right? I thought, okay, I think I know what this is. And so it was confirmed. So they're taking that renewable natural gas, they put it in their power plants, okay, which of course, then when their power plants are producing electricity for electric vehicles, et cetera, it brings down overall, right, their carbon intensity value. But that's courtesy, again, right, of renewable natural gas.
Yeah, that's great. And we can't emphasize enough, kind of following on what you're saying as far as where the gas is coming from, what the sources are. That molecule of CH4 that was produced by rotting palm trees and dinosaurs is the same as what's coming out of anaerobic digesters in the Midwest. It's the same. CH4 is CH4.
That's exactly right. It's the same natural process, right? It's just being controlled today versus how it happened over the millions of years underground.
Right. And so along, you mentioned pipes, and I think that's probably the next thing, or perhaps the next obstacle, maybe not so much the pipes, but okay, so we've got these pipes running all over the United States, moving natural gas hither and yon, but it doesn't just magically come out of these force mains into the trucks. And so talk about the distribution process of gas.
Yeah. So, Tom, I think you had a figure for how many fueling sites there are for compressed natural gas and the liquid natural gas, but it continues to grow. I don't know what that number is, Tom. Do you have that handy?
So yes, I do. As a matter of fact, I do. And so right now we're looking at 451 natural gas stations that are Class 7, Class 8 ready. And for our listeners, vehicles in the U.S. are classified from Class 1 all the way up to Class 8. So you may know somebody that has like could be, possibly a Ram, right, pickup, and maybe it's a heavy duty pickup. And it could be a friend that has a Ford, maybe it's an F-250. That would be considered a Class 2, right? And so that is relative to vehicle weight, right? And that helps to determine safety requirements, right? Also registration fees, because the weight of the vehicle, can compromise road integrity. So The larger the truck is, right, the greater, obviously, the registration fees, that sort of thing. But anyway, so Class 7, Class 8 would be your regional tractor trailers. And say regional will be like a day cab truck. You'll see them. UPS has a lot of them, et cetera. A lot of companies do. And they don't have, say, a sleeper cab. Okay, so you would just see good sized truck, pulling a load, doesn't have a sleeper cab, okay, and that possibly, depending again on total gross vehicle weight, it could be Class 7, maybe Class 8, okay, and then of course the largest ones, sleeper cab, okay, that's going to be your Class 8. Those are going to be your long haul trucks, right, going cross country. That's why they have the sleeper cab, obviously. And so when we talk about, say, being able to fill up a vehicle, it's one thing to have the fuel, but you have to have the capability. That was a great point that you raised there, Andrew, about the stations, right, and availability. So you've got 451 natural gas stations with renewable natural gas. Okay, this information you can get, quickly. This is the Alternative Fuel Stations Locator. You can get that online quickly. It's through the Department of Energy. And I've been studying this thing for years, and it's interesting to see how the stations evolve, the numbers grow. But anyway, so 451 natural gas stations, renewable natural gas, that can fuel Class 7 and Class 8 trucks, okay? They can handle them. That has to do with fueling pressures, 3,600 PSI, for instance, and below, but it's got to be able to accommodate a large truck as well. So then you look at electric, right? And electric, there's only 4, okay, right now, the DOE as posted, that can handle, say, Class 7, Class 8 truck. That's it. They're all in California. That's not much, right? And so the numbers really, tell the story. And these stations, these 451, they're spread out across the country, right? So they're in places where, as far as travel is concerned, not an issue. Okay, and it was, about 5 years back, I ran into a fellow, took his natural gas truck. He took it from Canada. He had no qualms with doing this, no concerns. Drove it from Canada all the way down to Long Beach, where we were having the Advanced Clean Transportation Expo, right, at that time, when it was held in Long Beach. It's gotten so big, it's no longer held there, but I went to Anaheim. So anyways, he made the trip, and he had no problem with it because he knows those stations, right, are available. Now, that was before the X15N, because now what is the range up to now, David, with the X15N?
Yeah, with the X15N and the packaging of fuel delivery systems, easily you can get 100 or 700, 800 mile range on a tank. You can add more tanks to the vehicle, so that adds more capacity, more range, and we have trucks that go over 1,200 miles range with those added tanks. And I think that's part of it. It's the planning. What are you really going to do? What's your route going to look like? To how much fuel capacity you put on that vehicle, and those fueling stations. I think Tom really nailed it there. Like in the obstacles is education, becoming familiar. Because I think one of the things, for a fleet who looks to this transition to natural gas, start decarbonizing with renewable natural gas, it's partnering with Cummins, partnering with the truck OEM, the dealer, and then the fuel provider, right? Who's going to provide your fuel and where are you going to fuel? That's something you don't really have to think about with the diesel truck because you kind of just take for granted it's there. You use it every day today. But the fueling companies, the energy companies, all have teams that are working on this decarbonization. So, getting them involved in figuring out whether it's fueling publicly or fueling and getting a private fueling, put in behind your fence so you can operate. And then, so that's really, partnership and education are really kind of key to that whole transition.
Yeah, and there's, I would add to that, of course, there's a bipartisan effort underway, right, in the Senate and the House with the renewable natural gas tax incentive. That would be, if passed, right, would pave the way for $1 per gas gallon equivalent, right, for every gallon, right, of RNG used. So that's something that people, if interested, should get behind, right? And that can make a difference, right, in terms of use and increased distribution.
Yeah, that's interesting, Tom. My brain is going to the fact that in my eyes, RNG supply and demand is really a chicken and egg type of issue. What comes first? What's the push and the pull to really bring this all further to market? So how can the transportation market and the RNG market, or maybe RNG producers and distributors, all work together for mutual benefit to move the needle in the direction of growth, to grow that RNG supply, but also to keep driving more demand for it too?
There's more opportunities, certainly. And so if it's something that a fleet is interested in, they don't necessarily have to take a giant leap. There's a lot of stations, as I mentioned, across the country, and even in my own city, Panama City, Florida, it's only $1.99. That's it, and it's widely used. And this would be mostly by sanitation truck companies. We've got a couple big ones, but I've seen pickups there, and we still have some the smaller sedans, CNG powered sedans, rolling around. And so there's opportunities, I think plenty of them, for them to get their feet wet, right, to go ahead and get acclimated. And again, the testimonials, reaching out to others that have been there, done that, and use the fuel. And I think sharing those testimonials, right, when you've got folks like Ozinga and others, and meeting with them, hearing what they've got to say, right. And I think the RNG Coalition, there's other advocacy nonprofit groups that can be a great bridge, okay, between fleets and these technologies. And that's something I've looked at for years. That's a great source. The nonprofits. You've got NACFE, right, David? NACFE's been hard at work for a long time.
Yeah, definitely. In fact, they're just now doing their boot camp on the messy middle. So we just did one yesterday for decarbonizing with renewable natural gas. So if you haven't had a chance to see that, that's a good one.
Yeah. I mean, and that's the thing to do, right, is to get educated, get informed. And thankfully, the web affords us that opportunity more than ever before, right? Mm-hmm. Reaching out to those groups. And they publish, NACFE publishes periodically their findings, and they're pretty darn amazing, pretty eye-opening. They got a lot of great participants. These are major companies that we've all heard of that are jumping in and trying renewable natural gas, right, and other technologies.
Could you break down what's the organization, the full name? I'm not familiar with the acronym.
NACFE. It's the
NACFE. What's that?
North American Council for Fuel Efficiency, or is it Freight Efficiency?
Freight Efficiency.
Okay. Great. Yeah, I figured it was something of the sort, but just didn't know what it actually stood for.
We get caught up on our acronyms, and that's right.
Well, talk about a sustainable sounding organization, a sustainable geared organization.
One of the things that I've listened to a couple of your all's podcasts talking about some of the work that's going on with your customers in bringing some of these bio waste to become renewable natural gas, right? Get them into digesters, and that's the thing is, right, we are going to continue to create waste, and how do we manage that liability in a sensible and sustainable way? And whether it's dairy digesters and managing that manure stream, or landfills, or I'm learning about feedlots thanks to you guys, and and everything in between. Some of these states and areas are diverting some of the food waste into digesters instead of going to landfill. Get you pure RNG for that. And, it's all about scale, because there's a capital investment to do these things. And, the efficient way to do it is bring scale to it. And that's the most sustainable way to manage this waste stream.
Well, I tell you what, Tom or David, you keep talking like that. You might be hosting the next podcast.
Seriously,
but and so we've talked about using RNG for over the road trucks. And we know that they're in bus fleets and any number of things, any number of other uses. But the one thing we haven't touched on is agricultural operations, particularly thinking about it in terms of agricultural field operations. And because we know that all of these farms and feedlots and dairies, they have substantial cropping operations and they use substantial amounts of diesel fuel just as a part of putting food on all of our tables. And so are there any obstacles that need to be cleared in order to get RNG to be used on farms for say field operations?
Yeah, that's a great question. Actually, some farms have been using natural gas engines for decades, and what comes to my mind are some of the natural gas engines I know that Cummins has in like pump operations. So out in a cotton field doing irrigation pumps, or a rice farm. I'm sure there's other types of farms that happens in, but that was the market I was helping with. When you get into equipment, mobile equipment, then it starts talking about scale. And then, there's got to be demand, right? The higher cost of a natural gas vehicle or machine in the case of agriculture is, the real payback comes with burning fuel because it's a lower cost. If you're going for the economics of it, obviously it's all sustainable or from a greenhouse gas and NOx reduction. So, it's all very much agricultural engines are based off similar platforms as the diesel and natural gas engine. So it's really bringing scale to make it worthwhile to bring that equipment in, invest in the development of that equipment, and such. But some of those farm fields, they're sitting on top of a natural gas well.
Yeah.
When I think back in Arkansas and places like that.
Yeah. So I think what we're kind of getting towards is the capex. The capex would be potentially higher presently, but the fuel efficiency is better. Is that more or less safe to say? And
the cost of operation on the fuel because of the lower cost of fuel. So
right.
Yeah, so it's really just is there the opportunity there to make the derivative engine, because it does require different emission standards for off-highway agricultural engines, and then obviously the integration work that the vehicle OEM has to do. But
right.
It is an opportunity there. Obviously, fuel is amongst them, so to speak.
And so is it safe to say that, just like almost anything new, and when we start talking about doing anything to scale, is there room for the engine costs, say, to come down, or are those pretty much where they need to be in order to accommodate the RNG?
I think it's a matter of scale and time, and that's always our friend. But then there's competing with that is ever demanding lower emission requirements. So some things that go push and pulls in the whole frame of it all. More and more technologies being applied to engines to get the lower emissions, and the benefit of that is the better fuel economy. So I think we see that in diesel and we see it in natural gas engines as well. So we'll have to see how that plays out.
Excellent. Well, that's we'll be surely paying attention, because we're big fans of producing renewable natural gas, and therefore we're big advocates of getting it into vehicles and getting it used.
Certainly, we are bullish RNG.
Yep.
And with all that being said, Andrew, I think I don't have any more questions. Do you?
No, I think this has been fantastic.
This has, yeah. Just thank you so much to both of you, Tom and David. This has been a fun conversation.
Thank you.
Hey, thank you all very much. This has been fun.
It has, and I think I speak for our listeners that when I say I think everyone will really enjoy this episode. So with that being said, to all of our listeners, we appreciate your time and attention today as you've joined Andrew and Tom and David and I for a fun conversation on RNG in the transportation market from the perspective of Cummins Incorporated. And we look forward to being back with you again in a couple of weeks. Until then, thanks for joining the herd today.